Hello guys, a very good afternoon to all of you. I hope that I am audible and visible to all of you. Let me check just one thing. But let me check that whether I am audible or not, whether I am visible and audible or not. Hello guys, am I audible and visible? I hope that I am audible and visible guys. Just a second. Chalo, good. So we are good to go with the lecture then. We are good to go with the lecture then. ठीक है? Good, good. So, guys, from today we are going to start with the gauge design part. आज हम पूरा gauge design करेंगे. We will solve questions related to limits and tolerance as well as the gauge design. Now, gauge design is a bit complex, so I would request कि आप जितना ज़्यादा और जितनी जल्दी इसको grasp कर लें, that is better. And if you are having any doubt, please let me know. Just a second, I'll arrange everything. Documents. Lecture 11. Good. चलो जल्दी से मैसेजेस कर दो, जल्दी से मैसेज कर दो, सब जगह मैसेज कर दो दैट पीपल शुड ज्वाइन इन. क्विकली मैसेज एवरीवेयर दैट पीपल शुड ज्वाइन इन. जल्दी से. आई एम ऑल्सो मैसेजिंग, यू ऑल्सो मैसेज. आई डोंट नो व्हाई सो लेस पीपल टुडे. I don't understand why so less people there are today. We would be starting it just in a minute. Just in a minute, we would be starting it. Good morning, good morning, good morning, good morning, good morning. Good afternoon हो गया अब तो. चलो quickly. I want every one of you to quickly wrap it up. जल्दी से मैसेजेस कर दीजिए अपने दोस्तों को सो दैट दे कैन आल्सो ज्वाइन. मैं थोड़ा लेट स्टार्ट करता हूँ एवरी डे, बट इट डजंट मीन कि आप लोग भी लेट आए. चलो pretty good. Separate PI session is not possible यार. Actually separate PI session is not possible. ठीक है, मैं सारी चीजें इसमें इंक्लूड करने की कोशिश करूंगा. अदरवाइज यू कैन कम इन द स्पेशल सेशन ऑन Unacademy Plus and you would be getting it. Not a very big deal. You will get it. You can ask your doubt. आप अपने डाउट पूछ सकते हैं, बट सेपरेटली पीआई के लिए एक पूरा कोर्स चालू करना, इट इज नॉट दैट फीजिबल, यू कैन से. चलो जल्दी से. I hope that I'm audible and visible. I hope that I'm audible and visible. Now I think that we are good to go with the lecture. So hello everyone. My name is Prakhar Shrivastava. I secured All India third rank in GATE 2016. Then I took admission into IIT Bombay and finally completed my master's from IIT Mumbai. From past 3 years, I'm teaching on an academy with an experience of teaching approximately 22,000 plus students. So thank you all for your love and support. The subject that I deal with is industrial engineering, manufacturing technology, and engineering mathematics. So thank you all, thank you all. Quickly join it. This is a crash course in manufacturing where we are dealing with. This is a crash course in manufacturing where we are dealing with the 80% of the most important topic that have been asked in the previous year question papers. तो देखो सारी चीजें आप लास्ट मोमेंट पे नहीं कर सकते, but yes we can do. Yes, PI के लिए preparation tips I will give. Don't worry about that, Mangesh. ठीक है? For preparation part, as far as preparation part is concerned, I will be giving it to you. Not a very big deal. I will be giving it to you. Not a very big deal. ठीक है? चलो. Quickly. Please message more people so that they can also join. Good afternoon, everyone. Good afternoon, Ayush Pathak. Good afternoon, everyone. Good afternoon, Rajan Soni, Khushbu, Devi Kiran, Prince Raj. Very good, Mangesh. Very good. Good afternoon to all of you. ठीक है, चलो. हेलो. हाँ मुझे बीच में चेक करना रहता है यार, पता नहीं ये आवाज क्यों चली जाती है बीच बीच में. ठीक है, नॉट अ वेरी बिग डील. एवरीथिंग इज कंफर्टेबल. शैल आई स्टार्ट विद द लेक्चर, देन let us go to the lecture directly. I'll be telling you about the plus and the iconic subscription just in a minute. First, you should see the quality of education you are getting on this channel. This is a crash course in manufacturing. This is a crash course in manufacturing presented by me, Prakhar Shrivastava. Presented by me, Prakhar Shrivastava, with a war cry of Pel Denge. Let us start with the lecture then. Give the heading gauge design. 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 Sir, what do you mean? Very good afternoon, everyone. Very good afternoon. Abhi आवाज and audio and video is clear to all of you. Yes or no? Currently, audio and video is clear to all of you. Yes or no? I hope that it is absolutely clear to all of you. I hope that this is absolutely clear to all of you. Good. Good. Chalo, good. Now we are good to go with the lecture, I think. Chalo. Let us start with the video then. Now, what is gauge design? Sir, what is gauge design? Sir, gauge design hota kya hai? So first of all, you need to understand, sir, what is gauge? What is gauge? So I have given you an example. Suppose you are going out to produce 50,000 pen. Suppose you are going out to take 50,000 pen. Now, in 50,000 pen, you require 50,000 bodies, and you also require 50,000 caps. You require 15,000 bodies and 15,000 caps. 50,000 caps. Now, bodies are nothing but acting as shaft, and caps are nothing but it is acting like hole. So now you understand a shaft and a cap. This is a pen with a cap. This is a pen with a cap. Body, cap. When you join body, when you insert the body into the cap, it forms an assembly. Pen is an assembly. You all understand now. When you are going out, you give the dimension. Sir, I want 50,000 bodies in the dimension of 1.9 to 2.1, and you want the cap between 2.1 to 2.3. This is the dimension that you are giving. This is the dimension you are giving. Yes or no? This is the dimension you are giving. This is the dimension you are giving. Now, if this is the dimension you are giving, you need to understand this one very important thing. You need to understand this very important thing. Sir, what do we need to understand, sir? What do we need to understand? Dekho, this is known as tolerance rule. We always provide tolerance. We always provide tolerance. We always provide tolerance. Yes or no? Because you cannot produce exactly 2 mm body, 2 mm cap. You cannot do that, guys. You cannot do that. If you cannot do that, you have to understand this very small thing. Very simple and a very small thing, that you have to give the range. Sir, I want bodies between 1.9 to 2.1 mm. That is fine. Absolutely acceptable. Absolutely acceptable. completely acceptable. Sir, बिल्कुल सही है. लेकिन you need to understand this one thing. How will you check? Now your acceptable range is, suppose I am taking whole. So your upper limit is 2.3. Your lower limit is 2.1. Sir, बिल्कुल सही है. Upper limit is 2.3 mm. The lower limit is 2.1 mm. ठीक है. ध्यान से देखो यहाँ पे. Upper limit is, just a second guys. Upper limit is 2.3 mm. Lower limit is 2.1 mm. Upper limit is 2.3 mm. The lower limit is 2.1 mm. Sir, कोई दिक्कत नहीं है, बिल्कुल सही है. But how will you check? So suppose you are checking this for hole. To check a hole, you require plug gauge. So you have two gauges of shaft. To check hole, you require plug gauges. Plug gauges look like shaft. Is it clear? So one is of 2.1 mm diameter. The other one is of 2.3 mm diameter. So any 50,000 pieces, you want to check your cap, you pick up a cap, you pick this 2.1. If a 2.1 mm shaft is going through your sample, what does that mean? The size of the sample is more than 2.1, accept it. Now, a 2.3 mm shaft is there, you pass the same workpiece to 2.3 mm shaft. Now this 2.3 mm shaft is not allowed to go. So what does that mean? That the size of this hole is less than 2.3. So you take 2.1, it is going. 2.4, it is not going, accept the product. Is it clear? Because it is in the range 2.1 to 2.3. I don't know whether it is 2.16, 2.17, 2.22, 2.29. I don't know that. I just know this one thing that your dimension, your workpiece is within 2.1 to 2.3. Your workpiece is within 2.1 to 2.3. Your workpiece is within 2.1 to 2.3. बिल्कुल सही बात. But if I ask my vendor, sir, I want a gauge of 2.1, will he or she will be able to provide it? No, because gauge is also a product and you cannot get the product of exact shape. You have to give the tolerance on product as well. You have to give the tolerance on gauge as well. आपका जो gauge होगा ना, that cannot be of 2.1 mm diameter. 2.1 mm diameter का नहीं हो सकता है. It will be 2.1, it will be 2.15, it will be 2.05, or there will be a tolerance. Is this thing clear till now? 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 ये चीज समझ में आ रही है आपको कि नहीं आ रही है, ये बता दो सबसे पहले तो. I hope that this is crystal clear to all of you. Now, very important. ठीक है, इसके बाद मैं आगे बढ़ता हूं. And now you understood this one very small thing, that your dimension cannot be 2.1 or 2.3. There will be some tolerance in gauge as well. मेरा जो check करने का instrument है, through which I am checking that whether it is equal, less than 2.1 or greater than 2.1, that instrument itself, it will be having some error. I hope you guys are understanding. If you have not liked the video, do like the video right now. समझ में आया? चलो, this thing is clear to all of you. So now we need to design the gauge in such a manner that my error is minimized. So if your checking device in itself having the error, this is your checking device. Your checking device in itself, it is having error. So don't you think your part that you are checking will also have error? अब क्या कर सकते हैं भाई? This is the niyam of the world that nothing can be produced without tolerance. So my checking device cannot be made 2.1 or 2.3. Is it clear? Now the objective is I have to design that what should be the size of the gauge. So you all understand from here. Suppose this is your hole. बहुत ध्यान से समझना. It is very confusing. I don't want you to create nuisance. I don't want you people to create nuisance. I hope you are understanding. नहीं समझ में आए पूछ लो, नहीं समझ में आए पूछ लो, बट प्लीज 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 बी अटेंटिव इन दिस पार्ट। इफ आई एम पुटिंग एफर्ट, आई रिस्पेक्ट like expect, you can say, effort from your side as well. Now this is your whole. The lower limit of the whole is 2.1, the upper limit of the whole is 2.3. Now whether this will be go lower limit will be checked by go gauge or no go gauge. See, this is 2.1. Now the 2.1 gauge, if it is passing through the workpiece, means the workpiece size is more than 2.1. This is the hole I'm going to check. This is the hole I'm going to check. This is the shaft I'm going to have. This is the shaft of 2.1. This is my workpiece that I need to check. If my 2.1 mm shaft pass through this, अगर मेरा 2.1 mm का shaft is passing through this hole, इसका क्या मतलब हुआ? मेरे hole का size is workpiece का size is more than 2.1, so the product will be accepted. So that is what do you mean by this? When your 2.1 mm shaft is going through the product, then your product will be accepted, and if it is not going through your product, means the size of the product is less than 2.1, it will be rejected. So when the product will be accepted, when the lower limit shaft go through the workpiece. So always remember, in case of hole, the lower limit is checked by go gauge and the upper limit is checked by no go gauge. That is same, simple. The lower limit is checked by go gauge, the upper limit is checked by no go gauge. The lower limit is checked by go gauge, the upper limit will be checked by no go gauge. ठीक है सर, ये तो सही है. अब ध्यान से समझना. You know that it cannot be made for 2.1. You know that it cannot be made for 2.1. तो आप कहां दोगे? The first case, you can say the value should be between 2.1 to 2.2. Yes or no? You say that the value of the gauge should be between 2.1 to 2.2. This is one way in which you can give the tolerance. The another way you are saying, नहीं नहीं नहीं, हमें अंदर नहीं देनी, हमें बाहर देनी. क्या होगा? व्हाट डू यू मीन बाय अंदर देने का टॉलरेंस, बाहर देने का मतलब? एवरीथिंग वी विल अंडरस्टैंड. व्हाट इज द सेकंड वे? यू से आई विल गिव बिटवीन 2.0 to 2.1. I will give between 2.0 to 2.1. Yes or no? So no go gauge can be look like this. That much the tolerance level on my no go gauge is 2 point, ऐसा लिख लो 2.15 कर लो से 2.15. So this is 2.25 to 2.30. This is my tolerance, or the tolerance can be outside also, 2.30 to 2.35. 2.35. This can be your tolerance. This can be your tolerance. Yes or no? Yes or no? This can be your tolerance. This can be your tolerance. Yes sir, this can be my tolerance. But sir, मैं अंदर की तरफ tolerance दूंगा कि बाहर की तरफ दूंगा? Whether I will be giving the tolerance through first method or second method, that I don't know. This is known as gauge design philosophy. So now you understand what we are going to find out in gauge design, the upper and lower limit of gauges. That's it. You are going to find out the upper and the lower limit of gauges. Is it clear to all of you? Is this thing clear to all of you? I want this thing to be clear to all of you guys. I want this thing to be clear to all of you guys. Quickly, 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 quickly. I want everyone to say yes or no. Now, in limit, fits and tolerances, you found out level 1. That is what is the upper and the lower limit of hole and shaft. That is what you have learned in limit, fits and tolerances. What is the upper and the lower limit of shaft? You learned this thing. What is the upper and the lower limit of shaft? But now you need to get a level up. What is the upper and the lower limit of go and no go gauge? This you can find out only and only if you know the upper and the lower limit of hole and shaft. जब तक आपको होल का अपर एंड लोअर लिमिट नहीं पता पड़ेगा, you cannot design the go or the no go gauge, because go and no go gauge is used to check this upper and lower limit. If you don't know the upper and the lower limit, how will you design your gauge? How will you design your gauge? Yes or no? So gauge design का पूरा फंडा समझ में आया? Is gauge design clear to all of you? Is gauge design clear to all of you guys? I just want to know that whether gauge design is clear to all of you or not, because this is important part. This is literally very important part. ठीक है, चलो let us start writing then. हम लिखना चालू कर देते हैं, इतना टाइम क्यों वेस्ट करें? कल भी हमारा काफी टाइम वेस्ट हो गया था, तो प्लीज स्टार्ट राइटिंग along with me. Please start writing along with me. लिख रहा हूं, 1 मिनट रुक जाओ। लिखो, गेजेस आर इंस्पेक्शन डिवाइसेस। लिखना चालू करो। गेजेस आर inspection devices. Gauges are inspection devices which are used to check. प्रॉपर नोट्स बना लो मेरे साथ, मैं बता रहा हूं बहुत बेनिफिट होगा, बहुत ज्यादा बेनिफिटेड। Almost 90% of the question will be from these notes. I'm telling you again and again. Don't take it lightly. Please make notes. Gauges are inspection devices which are used to check. Which are used to check. Gauges are the inspection devices which are used to check that whether the product is lying, whether the component produced is within the specified limit or not. It is within the given specified limit or not. It is within the given specified limit or not. अब gauges से क्या मैं absolute measurement करता हूं? No. तो write down. Gauges cannot give absolute measurement. इसके बाद लिखो, gauges cannot give absolute measurement. They are used in case of mass production. Mass production. They are used in case of mass production. ठीक है, लिखो, यहां लिखो, in case of mass production. I am not writing, guys. You guys write, I'll dictate. In case of mass production, ठीक है, in case of mass production, 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 if measurement is produced, if measurement is produced, if measurement is performed, if measurement is performed using measuring instrument instead of gauges, are performed using measuring instrument instead of gauges, instead of gauges, instead of gauges, it might consume heavy amount of time. 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 Therefore, therefore, it is wiser to use inspection devices instead of direct measuring devices. Therefore, it is wiser to reduce the inspection time. It is wiser to reduce the inspection time by using gauges. By using gauges. By using gauges. ठीक है, चलो, तो अब आपको एक चीज पता है that gauges comes in various format. When you give the heading gauges, first of all there are two type of gauges: plug gauge, which are in form of a shaft, and It is used to test hole. And the second one is the ring gauge to test shaft. To test shaft. Now, within this limit also, there will be the lower limit in hole is go, the upper limit is no go. The lower limit is no go here, the upper limit is go. The lower limit is no go in case of ring gauge and it is go in case of ring gauge. Upper limit is lower limit is no go and upper limit is go. ठीक है, यहां तक सबको समझ में आ गया? ठीक है, लिखो। इसके बाद कुछ इंपॉर्टेंट पार्ट्स हैं वो लिख लो। देखो, it is important, that's why you should write go gauge. Go gauge should enter the part. Go gauge should enter the part and no go gauge should not enter. And no go gauge should not enter. And no go gauge should not enter. Then only part will be accepted, otherwise rejected. Then only the part will be accepted, else rejected. Then only parts will be accepted or rejected. अब देखो, since it is not necessary to manufacture, since it is not possible to produce or manufacture anything without tolerance, since it is not possible to manufacture anything without tolerance, since it is not possible to manufacture anything without tolerance, so similar to work tolerance, gauge tolerance is also provided. So similar to work tolerance, gauge tolerance is also provided. This is 1 by 10th of work tolerance. This is 1 by 10th of work tolerance. Gauge tolerance is equal to 1 by 10th of work tolerance. ठीक है, अब आपको गेज के टॉलरेंस का वैल्यू तो पता चल गया दैट व्हाट इज द वैल्यू, व्हाट इज दिस वैल्यू यू ऑलरेडी नो, व्हाट इज दिस वैल्यू दैट यू ऑलरेडी नो। ठीक है, अब लोअर लिमिट होगी तो ऑटोमेटिकली मेरी अपर लिमिट तो निकल ही जाएगी। देखो, इसके बाद एक इंपॉर्टेंट बात लिख लो विच इज वेरी वेरी इंपॉर्टेंट। Since go gauge is continuously moving inside, since go gauge is continuously moving inside the part, hence it will be subjected to wear. गो गेज है, देखो नो गो गेज नहीं गया ठीक है, बट गो गेज को तो पूरा ट्रैवल कर रहा है ना बार बार एंड थ्रू द एंटायर लेंथ ऑफ वर्कपीस, सो डोंट यू थिंक सम वियर विल बी देयर, सम वियर विल बी देयर। तो लिखो सिंस गो गेज इज कंटिन्यूअसली मूविंग इनसाइड द पार्ट, since go gauge is continuously moving inside the part, since go gauge is continuously moving inside the part, since go gauge is moving continuously inside the part, it will be subjected to wear, it will be subjected to wear, and in order to compensate the wear, and in order to compensate the wear allowances should be provided on the go type gauge, the wear allowances should be provided on go type gauge। तो आपको पता चल गया गेज टॉलरेंस क्या होती है। चलो लेट अस मूव फॉरवर्ड, जस्ट अ सेकेंड आई विल कम बैक फ्रॉम वॉशरूम, आप तब तक ये नोट डाउन कर लो, बाय द टाइम आई विल कनेक्ट चार्जर आल्सो। हेलो, ठीक है, मेरी आवाज आ रही है, कैन यू हियर मी गाइस? यस मोहम्मद सलमान, यू आर राइट, स्लोली वी विल मूव टू फिलोसफी। पहले काम की चीज समझ तो लो। आई बी जस्ट बैक फ्रॉम वॉशरूम, बहुत जोर से टॉयलेट। बाय बाय, एक सेकेंड आ रहा हूँ। ओके गाइस, आई एम बैक। तो देखो व्हाट वी वर डिस्कसिंग, तो आपको गेज टॉलरेंस समझ में आ गया। गो गेज नो गो गेज क्या होता है क्या नहीं होता है ये पढ़ेंगे, बट आपको एक छोटी सी चीज ये समझ में आई दैट इन गो गेज वियर विल बी देयर, इन गो गेज वियर विल बी देयर। So don't you think you have to give wear allowance? Don't you think you have to give wear allowance? Obviously you have to give wear allowance. Obviously you have to give wear allowance. Yes or no? Comment section में लिख के बताओ. Yes, we require wear allowance or not. So you understood till now. You understood that in all the four cases you have to give the tolerance. Tolerance तो देनी ही है, because without tolerance you cannot make. But in case of go gauge, tolerance and wear allowance both should be given. Tolerance and wear allowance both should be given. Tolerance and wear allowance both should be given. टॉलरेंस एंड वियर अलाउंस बोथ शुड बी गिवन। कोई दिक्कत नहीं है भाई, बिल्कुल सही बात है। सो नाउ स्लोली स्लोली वी आर मूविंग टुवर्ड्स स्लोली, अरे यार वर्क टॉलरेंस है, दिस इज वर्क टॉलरेंस, ये याद रखना। वियर टॉलरेंस मत लिख देना, दिस इज वर्क टॉलरेंस। ध्यान से देखो, सब बनेगा। जस्ट हैव फेथ इन योरसेल्फ, दैट्स इट, दैट्स इट। इफ यू कैन लाइक द वीडियो, प्लीज डू लाइक द वीडियो, ऑल दोस पीपल हु हैव नॉट लाइक द वीडियो टिल नाउ। चलो, नाउ यू नीड टू अंडरस्टैंड दिस स्मॉल थिंग। ठीक है, सब कुछ सही चल रहा है। नाउ व्हाट इज द वैल्यू ऑफ वियर अलाउंस that you have to provide on go gauge? that is 1 by 10th of gauge tolerance, or you can say 1 by 100 of work tolerance. Is it clear? That's it. This is all you need to understand. And now we are good to go with the lecture. Now we are good to go. Now we are good to go. Now we are good to go with what? Now we are good to go with the lecture part. Now we are good to go with the lecture part. Is it clear to all of you? समझ में आया सबको? अब ध्यान से देखो क्या हो रहा है. आवाज तो आ रही है ना? बीच बीच में आवाज चली आती है ना कई बार. सो नाउ लेट मी शो यू how to design the gauges. Design of gauges. Please pay attention. This is really important. Suppose this is upper limit, this is lower limit. Try to understand. This is your upper and lower limit. Suppose I am checking this for shaft. The lower limit is 18, the upper limit is 20. You understand this thing? The lower limit is 18 and upper limit is 20. And this is nothing but shaft. So for shaft, you understand we require ring gauges. Ring gauge. And in case of shaft, the lower limit is no go, the upper limit is go gauge. ठीक है सर, बिल्कुल सही है, कोई दिक्कत नहीं है. Now I am giving the tolerance inward. This is my tolerance inwards. This is my tolerance inward. बिल्कुल सही बात सर, कोई दिक्कत नहीं है. Now, what is the value of this tolerance zone? This is 1 by 10th of work tolerance. So what is gauge tolerance? 1 by 10th of work tolerance. What is work tolerance? What is work tolerance? Work tolerance is 2. 20 minus 18 is 2. So gauge tolerance is 0.2. This is 0.2. This is 0.2. And this is also 0.2. Sir, ये तो आ गया. Sir, ये तो आ गया. What is the big deal in that? तो देखो. You need to understand the upper limit of go gauge is 20, the lower limit of go gauge is 19.8, the lower limit of no go gauge is 18, the upper limit of no go gauge is 18.2. Is it clear to all of you? Is this thing clear to all of you? Is this thing clear to all of you? So आपका आंसर आ गया. You already got the answer. The gauge, the go gauge is varying between 19.8 to 20 and no go gauge is varying between 18 to 18.2. सर बिल्कुल सही बात है, कोई दिक्कत नहीं है सर, बेहतरीन समझाया आपने. बट सर इसको बोलते क्या है? व्हेन यू आर गिविंग द टॉलरेंस इनवर्ड, this is known as job workshop philosophy. Workshop philosophy. What does, sir, what do you mean by that? सर दिक्कत क्या है, क्या हो रहा है, मुझे कुछ समझ में नहीं आ रहा. सर टॉलरेंस जोन मुझे समझ में आ गया. 1 by 10th वाला वैल्यू आई नो, 1 by 10th आई नो, प्लस माइनस आई नो. Sir, but what is the use? What is the difference if we give the tolerance inward or if we give the tolerance outward? Please, guys, pay attention here. Please, guys, pay attention here. Suppose in this case, this is your go gauge and no go gauge case. Please pay attention. Now you give the tolerance. Your go gauge comes out to be 19.9. Yes or no? Your go gauge come out to be 19.9. Suppose अब टॉलरेंस है, कोई भी साइज हो सकता है गो गेज का. यू कैन नॉट से. सपोज योर गो गेज इज 19.9 नाउ and your no go gauge is 18. Suppose it is 18. Both are acceptable, so your gauges are acceptable. Now a workpiece come inside. Now a workpiece enter. Now a workpiece enter. Sir, what do you mean by that? The workpiece is 19.95. Now your tolerance zone of the shaft is between 18 to 20. So ideally it should be accepted or rejected. It should be accepted. This is a good product na, because my work, because the range that I am accepting is between 18 to 20. The range I am accepting the shaft is between 18 to 20, 18 to 20, 18 to 20. So 19.95 is acceptable. But please check back. Now if you check the no go gauge is 18. The shaft is 19.5. Will it go? No, sir, it will not go. Accept karo. Then second stage is go gauge. Now go gauge is 19.9 and this workpiece is 19.95. Will it go? No, sir, it will not go. This is 19.90 and the workpiece is 19.95. So it passes the no-go gauge, but it fails in the go gauge. So the result is the product will be rejected. The product will be rejected. So do you understand? If you are giving the tolerance inward, if you are giving the tolerance inward, you are rejecting some good pieces. You are rejecting some good pieces. देखो आप कुछ exactly 20 and 18 cannot be made, so some value will be there. By chance no go gauge is exactly 18 but go gauge is 19.9. You cannot do anything about it. You have to give the tolerance. You have to give the tolerance. अब आपने अगर tolerance दे दिया है, so nothing was wrong but some good part is rejected. अब क्या कर सकते हैं? क्या कर सकते हैं? So that is why in this case some good part will be rejected but no bad part will be accepted. But no bad part will be accepted. That is workshop philosophy, that we cannot accept. मैं लिखवा दूंगा, don't worry. We cannot accept some bad parts. We cannot accept some bad parts. For that, if we have to sacrifice some good part, that is okay. ठीक है, ये चीज समझ में आई. अभी डरना नहीं है. अभी सेकेंड टाइप देखो, when we are giving outside. So second philosophy is inspection philosophy. Try to understand. Same thing is there. Same thing is there. Now, you know that your shaft is between 18 to 20. The acceptable limit of your shaft is between 18 to 20. The acceptable limit of shaft is between 18 to 20. ठीक है सर, बिल्कुल सही है. Now, you know that this is shaft, so the lower limit will be checked by no-go gauge. The upper limit will be checked by go gauge. This is clear to all of you. Now, you are giving the limit outwards. You are giving the limit outwards. What will be the limit? This point is 20. This is 20. This value is 2. If your work tolerance is 2, your gauge tolerance will be equal to 0.2. By now everyone understand this thing. Yes or no बोलो. पहली बात यहां तक समझ में आया कि नहीं, और आया तो crystal clear है कि नहीं? I want everyone to write crystal clear if you are clear with this part. Please guys, quickly, I don't want any nuisance from your side. जल्दी बताओ. Quickly tell me, is this thing clear to you or not? I hope that this is crystal clear to all of you. I request you all to please reply whenever I am asking. If you don't reply, then I'll just teach and go. I want you to participate in the discussion. I want, if you are having any issue, I should be able to answer to that question. Come on guys, please do participate in the comment section. Now, the upper limit is 20. The upper limit is 20. This is 0.2. So what is this value? 20.2 हो गई है. Similarly, if this value is 18, this is 0.2, so this is 17.8. Now you know the go gauge is varying between 20.00 to 20.20, and the no-go gauge is varying between 17.80 to 18.00। बिल्कुल सही बात है। 17.80 से लेके 18.00 तक इट इज वेरिंग। दिस इज द लिमिट, दिस इज द इंस्पेक्शन फिलॉसफी। नाउ इस फिलॉसफी का दिक्कत क्या है वो समझो। सपोज योर गो गेज इज 20.10 and your no go gauge is 17.90। simple, your no go gauge is 17.90, your go gauge is what? Your go gauge is 20.10। now very important, suppose your workpiece come, the dimension of the workpiece is 17.95, the acceptable limit is 18 to 20, the acceptable limit is 18 to 20, the acceptable limit is 18 to 20, so don't you think this part should be rejected? Don't you think this part should be rejected? Sir, बिल्कुल reject होना चाहिए। Why not it should be rejected? Because it is 17.95. The acceptable limit is 18 to 20. Why it should not be rejected? Why it should not be rejected? Reject क्यों ना हो ये बताओ आप तो। बिल्कुल सर rejected होना चाहिए। लिख लो rejected दिखा, rejected दिखा कि नहीं दिखा? बिल्कुल दिखेगा। So it should be rejected, sir, बिल्कुल it should be rejected. Now my friends, will it pass? Will it pass through no-go gauge? No-go gauge is 17.90. 17.90. The product is 17.95. The product is 17.95. The 17.95. Will it go through 17.90? No, it will not go through 17.90 and hence it will be accepted. Will it go through 20.10? Obviously. So yes, if dono things are right, it will be accepted. So do you understand? Do you understand that when you are giving the limit outwards, some bad part will be accepted, but no good part will be rejected. If you are giving the limit outwards, some bad part will be accepted, but no good part will be rejected. No good part will be rejected. No good part will be rejected. So that is your inspection philosophy. That is your inspection philosophy. That is your inspection philosophy. Is this thing clear to all of you? If you have not liked the video, do like the video right now, right here. ठीक है, चलो अब लिखो workshop philosophy. Give the heading workshop philosophy, ये, and start writing. Start writing in workshop philosophy. Start writing in workshop philosophy. The philosophy of workshop gauge is that the philosophy of workshop gauge is that the philosophy of workshop gauge is that we will not produce anything defective. 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 So the direction of the gauge tolerance is towards the work tolerance. The direction of the gauge tolerance is towards the work tolerance. The direction of the gauge tolerance is towards the work tolerance. The direction of the gauge tolerance is towards the work tolerance. The direction of the gauge tolerance is towards the work tolerance. The drawback of the workshop gauge is that some of the good parts will be treated as bad parts. Some of the good part will be treated as bad parts and will be rejected. And will be rejected. And will be rejected. Is it clear to all of you? Is it clear to all of you? Some of the good parts will be treated as bad parts and will be rejected. And will be rejected. अगर लाइक नहीं किया तो बिल्कुल लाइक करो अगर ये चीज समझ में आए। ठीक है। Second philosophy is the inspection gauge philosophy. Inspection philosophy. So please note it down in inspection philosophy. Please note it down in inspection philosophy. It states that this philosophy states that फाइल आ जाए. This philosophy states that since a lot of efforts and resources are applied, since a lot of 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 resources are applied to manufacture a component, to manufacture a component, hence no good part will be rejected. Hence, no good part will be rejected. Hence, no good part will be rejected. Hence, no good part will be rejected. No good part will be rejected. Therefore, direction of the gauge tolerance, therefore, direction of the gauge tolerance is away from the work tolerance. The direction of the gauge tolerance is away from the work tolerance. Is away from the work tolerance. Is away from the work tolerance. The drawback of inspection gauge is that the drawback of the inspection gauges is that the drawback of inspection gauges is that some of the bad parts, some of the bad parts, some of the bad parts will be treated as good parts. Some of the bad parts will be treated as good parts, and hence they will be accepted. And hence they will be accepted. Since inspection type gauges, since inspection type gauges are already inaccurate, since inspection type gauges are already inaccurate, since inspection type gauges are already inaccurate, hence wear allowance is not provided in this case. Hence wear allowance is not provided in this case. Hence wear allowance is not provided in this case. Don't go anywhere, guys. We will be solving 3-4 good questions today. So देखो. Now this is your shaft. This is your shaft. Please see this diagram. This is very important diagram. If you learn this diagram, if you understand this diagram, you won't be facing any issue. अब देखो, this is 18, this is 20. You know that the tolerance zone is 2. 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 Now, in case of this is shaft, this is a shaft. So you know this one thing. In case of shaft, ring gauges are used. In case of ring gauges, the lower limit is a no-go gauge and the upper limit is the go gauge. Please pay attention. So that is why job shop philosophy will look like this. No-go gauge inwards. Go gauge is also inward, but go gauge में आपको wear allowance भी देना पड़ेगा. So that is why I am making it a bit small. Because when you are giving the wear allowance, automatically the size will reduce. Is it clear? So this is the value. This is the value for wear allowance. दिखेगा नहीं, बहुत छोटा लिखा है मैंने. But that value that we are leaving on go gauge side is wear allowance. Just remember this diagram, you will be able to solve 99% of the gauge design questions. Now, in case of no-go gauge, in case of no-go gauge, it looks like in case of inspection philosophy, the tolerance is given outwards, but tolerance in case of philosophy, in case of inspection philosophy, wear allowance is not given because already आप some extra material आप लगा रहे हो. You will not give wear allowance. You will not give wear allowance in case of no go gauge. So this is workshop philosophy. Workshop philosophy. This is inspection philosophy. Many people now when none of the philosophy is given in the question, workshop philosophy bhi nahi hai, inspection philosophy bhi nahi hai. If none of the philosophy is given, then there is a third type of philosophy, that is general purpose philosophy. General purpose philosophy. In general purpose philosophy, go gauge is taken from the workshop philosophy and the no go gauge is taken from the inspection philosophy. Is it clear? And that is why this is known as general purpose philosophy. अगर आप ये diagram याद रखेंगे ना, बिल्कुल दिक्कत नहीं होगी. If you remember this diagram, none of the issue will be there. Workshop philosophy, go gauge design करना है, you should know about this value. You should know about this value. Is it clear to all of you? Is it clear to all of you? ये चीज समझ में आनी चाहिए आपको. This should be clear to you. This should be clear to you people. Please try to understand it, guys. Please try to understand it. ठीक है, चलो इसके बाद देखते हैं. Now this is for shaft. Similarly we will do it for hole also. This is one important diagram. We will make it for hole also. Please remember this diagram. इसको frame करके लिख लो. In case of hole, this is your hole. Now suppose the size of hole is varying between 18 to 20. Same condition. Now in this case the lower limit will become go gauge, the upper limit will become no go gauge. Simple. For job shop philosophy it looks like this. This is for your job shop philosophy. No, both are towards inwards. Both are inwards. In this case both are outwards. मैं आपको बता रहा हूं कि कैसे सॉल्व करना है. You will be able to do it. And here no go gauge will be outward due according to the inspection philosophy. According to the inspection philosophy, no go gauge will be outward. According to the philosophy, no go gauge will be outward. No, we don't provide. मैं बता दे रहा हूं why we don't provide wear allowance in case of inspection. I'll tell you why. And go gauge design will be taken from workshop philosophy. Is it clear? Is it clear? So this diagram is equally important. This diagram is equally important. ठीक है, ये diagram बहुत ज्यादा important है आपके लिए. You should understand this thing. You should understand this thing, that this diagram is very very important for you people. This diagram is very very important for you people. ठीक है, चलो. Now suppose this is there, this is go gauge. In inspection time, if you take wear allowance, it will make the gauge much more inaccurate because already the gauges are inaccurate in case of inspection type of system. In case of inspection type of a system, in case of inspection type of a system, in case of inspection type of a system, already the gauges are inaccurate. We cannot make it more inaccurate by giving the wear allowance. We cannot make it more accurate by giving the wear allowance. We cannot make it more inaccurate by giving the wear allowance. Is it clear to all of you? सबको समझ में आ गया कि नहीं आया? क्विकली टेल मी, इज दिस थिंग क्लियर टू यू और नॉट? बिट्टू एक बार देख लेना। चलो, let us take a question. Let us take a big question. For checking the shaft, simple. First you try, first the first value is, the first you will calculate the value of d. सबसे पहला स्टेप होता है, you calculate the value of d. What is the value of d? Then d is, now 25 is lying in the range of 18 to 30. 25 is lying in the range of 18 to 30. So you write it here 18 into 30. You write it here 18 into 30. This is nothing but 23.23 mm. Second value is, you will calculate the value of I. Now I is equal to 0.45 d to the power 1 by 3 plus 0.0001 0.001 d. Now you will enter the value of d in mm. The answer you will be getting in microns. So this is 1.386 microns. Microns is not a very good unit. Microns is not a very good unit. So you have to convert it into mm. 0.0013 mm. This is the value of I. This is the value of I. This is the value of I. Third step is draw diagram. Step number 3 is draw diagram. Draw diagram. How will you draw the diagram? You will first open up the baseline. You will first draw the baseline. This is your baseline. Now you will be drawing H. Capital H represents the hole and capital H is placed like this. We know this thing. Small h is placed like this. This is your shaft. Now you know this value is IT6. IT6 is nothing but 10I. जो मैंने आपको टेबल दी थी ना, from that IT6 is nothing but 10I. 10I is nothing but 0.013 mm. Okay, this is also IT6. This is also IT6, which is nothing but 10I. 0.013 mm. Is it clear? Now, this is hole, this is shaft. What is the upper limit of shaft? Upper limit of shaft is 25 only. Because this is lying on baseline. It is lying on baseline. I'm not able to see your comment, guys. I'm not able to see your comment. Baseline. Please comment in the section यार, तो मुझे थोड़ा समझ में आ जाए. Now, this is your shaft because it is represented by small letter. The lower limit of shaft will be 25 minus 0.013 is equal to 24.987 mm. This is the lower limit. 24.987 is the lower limit. 24.987 is the lower limit. So आपकी shaft की lower limit आ गई. The upper limit of the shaft will be 25 plus, ऊपर जा रहे हो ना तो 25 plus 0.013. So this is 25.013. Is it clear? This was the first step. Till this we have learned in limit, fits and tolerances. Now you have to design the gauge. Now to design the gauge, you will again draw. Now nothing is given. If nothing is given, you will use the general purpose theory. You will use the general purpose theory. So you will just draw the line for shaft. You will just draw the line for shaft. This is your shaft. What is the lower limit of shaft? The lower limit of shaft is 24.987. The upper limit is 25. 24.987. This is 25. Now, you have to draw according to general purpose theory. So first of all, this is shaft. So lower limit is no go, upper limit is go gauge. Now, go gauge will look like this. The no-go gauge will look like this. Is it clear? The go gauge will look like the above one and the no-go gauge will look like this. Now, you just need to calculate this value. What is this value? Oh. What is this value? This is 0.013. So, work tolerance is 0.013. Gauge tolerance will be 0.0013, 1/10 of the work tolerance, and wear allowance will be much smaller, that is 0.00013. Okay, now very important part is this. Calculation error यहाँ पे होती है, सबसे होती है, मुझसे भी होती है. That is not a very big deal. So that is why please be attentive. Now you know this is 25. So now what will be the upper limit of go gauge? What will be the upper limit of go gauge? 25 minus wear allowance. What is wear allowance? 0.00013. What is this value? 24.99987. 24.99987. बिल्कुल सही है भाई, बिल्कुल सही है. क्या दिक्कत है? 99987 बिल्कुल सही है. That is the upper limit of go gauge. Now, what is this tolerance zone? 0.0013. So, what is the lower limit of go gauge? 24.99987 minus 0.0013. Now, what will be this value? What will be this value? आपको calculate करनी पड़ेगी ये value. So this is 5857, 99857. 24.99857. This is your lower limit of go gauge. This is your lower limit of go gauge. Similarly, you can calculate upper and lower limit of no go gauge also. This is also 0.0013. So the upper limit of no go gauge is 24.987. Lower limit of no go gauge is 24.987 minus 0.0013. 9857. 24.987. This is the lower limit. So now you got the upper and the lower limit of go gauge. Shaft के लिए जो go gauge use हो रहा है, you have the upper and lower limit of that value. Upper and lower limit of no go gauge. Is it clear? You have everything clear. Now you know how to use the limit, fits and tolerances to find the upper and lower limit of work shaft and hole. Beyond that, you also know how to find out the upper and lower limit of go gauge and no go gauge. Is it clear? Is this thing clear? I hope that this thing is crystal clear to all of you. किसी को कोई डाउट हो तो फटाफट बता दे भाई. किसी को कोई भी डाउट हो तो प्लीज लेट मी नो. ठीक है? By the time I will get you some benefits of plus subscription. So see, you have seen the quality of education here. I always focus study less but revise more number of time, practice more number of time. If you study so much, it will be hectic for you to revise and then you leave the preparation. When you get under pressure ना, आप preparation छोड़ देते हो क्योंकि बहुत सारा content हो जाता है. So that is why study less, study that is required. We are there to guide you throughout your preparation. We have ourselves secured the rank, so I don't think you would be having any issue. You would be getting the live classes in plus subscription, which is a paid course. You would be getting the crash courses, the rank improvement batch to basically practice more number of questions. You would be getting the weekly test to monitor your growth. You would be getting the doubt clearing session to basically doubt clearing session every 3 days. And yes, The sessions will be conducted in English and Hindi. Parallelly, if you want something extra, you can take the iconic subscription. You can take the iconic subscription where you will be getting a personal coach. You will be getting a personal coach, that is one-on-one guidance will be provided to you. ठीक है. Study planner, that is when to study, what to study and how to study. Then you also being provided with the preparatory study material, that is you don't have to go here and there searching for the study material on this and that Telegram channel. You would be provided with the better, like you can say, study booster sessions. You will be provided with the study booster session to motivate yourself throughout your preparation. And my personal favorite, your test analysis will be provided to you so that you can find out your weak areas. Okay, what are the charges? So for plus subscription, the charges are 27,225 rupees for 1 year, 34,650 rupees for 18 months, 39,600 rupees for 2 years. When only and only when you apply the code crack10. ठीक है, only when you apply the code. Which code you need to apply? You can apply crack10 or you can also apply Prakhar21. You can also apply Prakhar 21. You can also apply Prakhar 21. You can also apply Prakhar 21. Is it clear to all of you? आप कोई भी कोड कर सकते हो. Now, what are the charges for iconic subscription? It is 45,225 rupees for 1 year and 66,600 rupees for 2 years. Only and only when you apply the code Prakhar 21. Only and only when you apply the code Prakhar 21. Is it clear to all of you? Apart from that, if you want to follow me, you can follow me on this particular link, that is unacademy.com@Prakhar. You would be given with all the various, you can get all the free classes, that is the free special classes, where currently I am running 500 questions in manufacturing. 500 questions in manufacturing. 500 questions in manufacturing. So you would be provided with that. Secondly, you can follow our whole team on this Telegram channel. यहाँ पर भी सारी लिंक पोस्ट होती हैं. And then these are the YouTube channels that we are running right now. That is Unacademy Gate, MEPI, XC, Unacademy Gate Questions, and Unacademy SSCG. ठीक है, और भी है, but they are for different branches. So I hope that you have enjoyed today's session. And thank you for watching the video. I hope आपको gauge design crystal clear हो गया होगा. Tomorrow we will solve some more question, and tomorrow we will start with very important parts, that is linear and angular measurement. Tomorrow we will start with linear and angular measurement. That's it. Linear and angular measurement. किसी को और कोई डाउट है? 5 minutes I will wait and then I'll be closing the lecture. If you are having any doubt, please let me know. Please let me know if you are having any doubt. Thank you, all the best. Let us meet tomorrow. Let us meet tomorrow. कोई डाउट हो तो बताओ. कोई भी डाउट हो तो बता दो. Not a very big deal. कोई भी डाउट हो तो बता दो. फटाफट. चलो. Thank you, all the best. Let us meet tomorrow. Bye bye. चलो.